Welcome to KOM lecture. Myself P. Senthilkumar, faculty in Mechanical Engineering. In this lecture, we are going to discuss about 4-bar mechanism. The main objective of this lecture is to understand the working methodology of 4-bar mechanism. The specific objectives are to explain the working of 4-bar mechanism, to classify the various types of 4-bar mechanism, to show the application of 4-bar mechanism in beam engine and coupled rod of locomotive. Finally, to find the velocity component of 4-bar mechanism. Let me explain the application of 4-bar mechanism in a car. When I press wiper lever, it actuates motor which create an oscillating motion on windshield. Now my question is, how does it work? I mean, the motor create rotary motion, but at the output we are getting oscillating motion. There is an arrangement between the motor and wiper. That arrangement converts the rotary motion of motor into an oscillating motion of wiper at the output. That arrangement is nothing but 4-bar mechanism. The purpose of the 4-bar mechanism is to convert the rotary motion of motor into an oscillating motion of wiper at the output. Specific objective 1, to explain the working of 4-bar mechanism. This is an arrangement of 4-bar mechanism. This is the working model of 4-bar mechanism. Here, the rotary motion of crank converted into an oscillating motion of rocker at the output with the help of connecting rod. Link 1 frame which is fixed, link 2 crank, link 3 connecting rod, link 4 rocker. The simplest and basic kinematic chain is 4-bar chain. Here the degree of freedom is n equal to 1. N equal to 3 into L minus 1 minus 2j. 3 into number of link 4, 4 minus 1 minus number of joint 4, 2 into 4. So 9 minus 8, that is equal to 1. Degree of freedom 1. That is why it is called simple mechanism. Grashoff's law states that sum of the shortest and longest link should not be greater than sum of the remaining link. Let us consider the 4-bar diagram. Here the shortest link AD and longest link BC. So AD plus BC less than, which means should not be greater than, so less than remaining link AB plus CD. So this is a condition to be satisfied for a 4-bar mechanism. Specific objective 2, to find the various inversion of 4-bar mechanism. Inversion is the process of obtaining different mechanism by fixing different link. There are 3 possible inversion. First one, crank lever mechanism. The name itself give meaning. Crank lever. Crank act as an input, lever act as an output. The second one, double crank mechanism. 2 cranks act as a make complete rotation. The third one, double lever mechanism. Here 2 link act as a lever. Let me show you the simulation of 4-bar mechanism and its inversion. In this arrangement, add pin joint and motor on respective place. Fix link 1. This is a simulation of 4-bar mechanism. Fix green color link instead of blue color link. You can see a double crank mechanism. I mean 2 links will make complete rotation like this. Similarly, you can fix link 3, I mean orange color, to see the animation of the arrangement. When you fix link 4, you can see a rocker motion. I mean 2 links will make an oscillating motion. These are the 3 possible inversion in 4-bar mechanism. Specific objective 3, to show the application of 4-bar mechanism in beam engine and coupled rod of locomotive. First one is beam engine. This is an arrangement of beam engine. Let me show you the working model of beam engine. In this model, this is link 1, this is link 2, link 3 and link 4. When I rotate a crank about a fixed point, the lever oscillates about this point. Meanwhile, the slider slides inside the cylinder. This is the working of crank lever mechanism, I mean beam engine. The purpose of this mechanism is to convert the rotary motion of crank into a sliding motion of slider inside the cylinder. Next one, coupled rod of locomotive. This is an arrangement of coupled rod of locomotive. When the crank 1 at wheel 1 rotates about a fixed point, the crank 2 at wheel 2 will also rotate with the help of connecting rod. The purpose of this mechanism is to convert the rotary motion of one crank into another crank. The distance between 2 points is fixed in order to maintain a constant distance between wheels. That's why this mechanism is commonly used in locomotive. The specific objective 4 is to resolve velocity component for 4-bar mechanism. Let us consider a 4-bar mechanism like this. A, B, C, D. Now apply law of relative velocity. Velocity always perpendicular to link. So draw VBA perpendicular to BA. Then draw VCB perpendicular to CB. Finally draw VCD perpendicular to CD. First move blue color line VBA. Next move green color line VBC. Then finally move orange color line VCD like this. By measuring the length of these lines, we can find velocity of individual component. Stimulating question. Identify the type of mechanism used in the following toys. The answer is double crank mechanism. It acts as a double crank, oscillating body. The floor acts as a fixed link. Link 1, link 2, link 3, link 4. When I fix oscillating body, it simply make rotary motion. Now you can see it simply make rotary motion. That's it. Let me show you once again. Double crank mechanism and a type of 4-bar mechanism. There are a lot of mechanisms used in toys. This is one example, walking mechanism used in toys. I will show you one more example, a walking mechanism using cam. So in real world you can find a lot of mechanism like this in toys. Let me conclude today's lecture. Today we discussed about 4-bar mechanism. In that, first we discussed about different terminologies along with Grashoff's law. Then we discussed about inversion of 4-bar mechanism, crank rocker, rocker rocker and double crank mechanism. Then we discussed about applications like beam engine and coupled rod of locomotive. Finally we discussed about kinematic analysis of 4-bar mechanism. Next class we are going to discuss about slider crank mechanism. Thank you. Have a nice day.